Hey, welcome to Draft Academy. My name's Mike. This video is part of a series of videos where I'll be going over the basic syntax of different programming languages. Now, one of the most annoying things about picking up a new programming language is having to learn all the syntax from scratch. In my own experience, it generally manifests in a lot of Google searching and Stack Overflow. For an experienced developer, the problem isn't understanding the concepts of programming, it's knowing how to implement those concepts in the new language. So things like variables, data types, data structures, loops, conditionals, and object orientation. All of these things are done a little bit differently in each programming language, and having to research how to do it all can be extremely annoying and tedious. In this video, I'll go through and show you the basic syntax for the most common parts of the language. I'll give you a brief history of the language, and we'll touch on some of the best practices and conventions used in that language. Now, this is meant to be a quick run-through. I won't be showing you how to install or configure anything, and we won't really have time to learn how to do everything. You see, I've distilled it down into what I consider the core concepts, so the goal for this is to be a quick video, so I can't cover every aspect of the language. With that being said, this video is meant for programmers who already understand the core concepts of programming. It's not going to teach you any programming concepts. I'll simply show you how to do all the common things in the new language. So if you are new to programming, Draft Academy has hundreds of videos where I hold your hand and I walk you through everything you need to learn to program, but this is meant for developers who already understand programming. So without further ado, let's get started. Java is a general-purpose, statically typed, object-oriented programming language that was founded in June of 1991. The project was initiated by three developers, James Gosling, Mike Sheridan, and Patrick Naughton, but was officially released by Sun Microsystems in 1995. Java's tagline is write once, run anywhere. All Java code is first compiled down into a special language called Java bytecode, which is then run on the Java virtual machine. And because we're using the Java virtual machine to run our Java code, this ensures that Java programs can be run on virtually any combination of hardware and operating system. Hence, write once, run anywhere. Java uses an automatic garbage collector to manage memory, and the syntax of Java is largely influenced by C and C++. Java is perhaps best known for being the language in which Android apps are written, and also serves as the basis for several popular frameworks including Spring and Hibernate. Java is also known for having an extensive ecosystem and libraries and APIs to do just about anything. In fact, there are billions of devices that currently run on Java. So you know that the ecosystem is really fleshed out. Many developers choose to write Java using a specialized integrated development environment, or an IDE. Three of the most popular are Eclipse, NetBeans, and IntelliJ. So let's go through and I'll show you guys how to do some of the most common things in the Java programming language, and I'll just give you a full introduction into how to use it. The first thing I want to show you guys is this file I have set up over here. This is app.java, and generally when you're creating a Java file, you want to name it with a capital letter, and then inside of that file, you're going to have a corresponding class. So the file is named app.java, and I have this app class, which I declared by saying public class app. A lot of times when you're working in Java, you'll be writing your Java in an IDE, in which case the IDE will take care of running your Java programs for you. But if you want, you can just run them straight from the command line over here. So if I wanted to run this program, I just have to go to the correct directory, and then I could just say JAVAC, and this stands for the Java compiler, and then the name of the file, so app.java. I'll click enter, and what this is going to do is it's going to compile this file and create this .class file. And this is the file that has all that Java bytecode. So this file can actually get run on the Java virtual machine. If I want to run this file, I can just type in Java and then just app. So this is going to be the name of the class, and I'll click enter and it'll go ahead and run it. Now, inside of your Java class, you can have this method over here, which is public static void main. This is the main method, so any code that you put inside of here is going to get executed when you run that file. So let's look at some code that we can put in our Java programs. First thing I'll show you guys is printing. So down here I have an example of how we would print something out in Java. It's just system.out.println. So there's two of these print statements. You can do println, we would call this print line. And basically what this will do is it'll print out whatever we put over here, and then it'll print a new line after it. Or you can just say print, and this isn't going to print a new line after it. So from this code, you'll see that we get this output over here, hello world with an exclamation point. Now we'll take a look at variables. So variables in Java, the names are case sensitive, and variable names can begin with letters, a $, or an underscore. after that first character, you can have letters, numbers, a $sign, or an underscore. Generally, you're going to start a Java variable with a letter. And convention says to start the variable name with a lowercase word, and then any additional words are going to be capitalized. So for example, down here we have my first variable. So Java is statically typed, which means we're going to have to rigorously define what data type we want to store in each of our variables. The first one we have here is a string, and string just holds a string of text. You'll see that we can delineate a string using double quotation marks. Then down here we have a character, and a character is going to use single quotation marks. Character can hold one single 16-bit Unicode character. And down here we have numbers. So the first type of number would be like a whole number or an integer. And there's a couple different types of integers that we can represent. We can represent a byte, which is going to be an 8-bit signed 2's complement integer. Then we can have a short, which is going to be a 16-bit integer. We have just the regular int, and this is going to be the default when we're working with whole numbers. And that's going to be a 32-bit signed 2's complement integer. And then finally down here we have a long, and this is just going to be like a 64-bit optionally signed 2's complement integer. And you'll see here when I create this long, I put this L after the number. That just tells Java that it's going to be a long. And down here we have floating point numbers. So these are decimal numbers. So I have a float. And a float's a 32-bit floating point. So you'll see down here after the number, I put this F that just delineates that it's a float. And then I also have a double over here, and that's a double precision 64-bit floating point number. And then finally down here, we have our 1-bit Boolean. So this is gonna hold a true or a false value. And I also wanna show you guys down here, I can declare the variable, like declare the name. And then over here, I can give it a value. So you don't have to give these values initially. And also, if you want, you can modify a variable just like I did down here. And then down here, you'll see that I can actually print out these variables. So here I'm just saying system.out.println. One way you can do it is with concatenation. So I'm concatenating this string with the value that's stored inside the variable. You can also use this printf function. So if you're coming from like C or C++, you're probably familiar with this. And I'm using this %s to delineate that a string needs to go there, and then I'm passing in the string as a parameter. And then down here you'll see I have this little chart that just says what should go inside of that printf function. So these are going to delineate the different data types. And then over here you'll see that we're just printing out your name is John. All right, so now that we've talked about different data types and variables, I'm going to show you guys how we can convert different types. Again, because Java is statically typed, we need to be very specific about what types of data we're working with. So you can do casting. So I could take like, this is a double, so it's a floating point number, and I could cast it to an int. So I'm just putting int inside of parentheses here, and then afterwards I'm putting the decimal number that I want to cast. I can do the same thing with a double. So I have an integer here, I can cast it to a double. And you'll see over here, we're getting 3 and then 3.0 from 3.14 and 3. So those are getting cast. You can also convert a string into an integer or a double. So if you have a string that has a number like trapped inside of it, we could just say like integer with a capital I dot parse int, and then pass in the string. So this is going to grab an integer from here. You can do the same thing with a double. So I could say like double dot parse double, and this is actually going to take the double from here and the integer from here, and it's going to store them inside of these variables. And so you'll see down here, I'm adding those variables to 100, and we get 150 and 150.99. So that's how you can convert different types and cast different types. Let's also take a look at strings. So strings are one of the most common data types that you're gonna be working with in Java. You'll see over here, I just have this string variable. And again, strings are delineated with this quotation mark. And down here, we have the string indexes. So like most other programming languages, the indexing starts at 0. So we would say character H is at index position 0, and then we kind of just go from there. So hello technically has 5 characters, but the last character's index is 4 because we start counting at 0. Down here, we have a bunch of different methods that we can use on these strings to get information about them or modify them. So greeting.length, this will tell me how many characters are inside of it. Char at is going to give me a character at a specific position. So if I say 0, we get this H. Index of is basically going to tell me at what index a specific string or character starts. So LLO, that starts at index position 2 in this string, and that's why we get 2 over here. Index of, if you pass in an invalid string or an invalid character, in other words, a string or a character that's not inside of the string, then it's going to return a -1. So that's always going to be consistent. And then we also have a substring. So you can pass in an index, and what that'll do is it'll grab the string starting at that index. So you'll see down here, substring of 2 gives us LLO. It's because it starts at 2 and it grabs all the rest of the characters to the end. You can also pass in an ending index. So in a lot of languages, this second number will be a length, but in Java, this is going to be an ending index. So it's going to start the substring at 1, so we'll start at E, and then it's going to end it at 3, but it's not going to include 3. So it'll just be EL, and that's why we get this over here. There's tons of these string methods. If you just Google Java string class, then you'll find all of these, and they're really useful. And all of the string functions that you would find in another programming language, you would also find in Java. Let's also talk about numbers. So in addition to text, we're also going to want to be able to work with numbers in Java. You see down here, I'm just printing out the result of multiplying two numbers. So we can multiply numbers. You can also add, subtract, and divide numbers, all the basic arithmetic that you would find. We can also use the modulus operator. So I can say 10 mod 3, and that's going to give me the remainder of the division. So it's going to divide 10 by 3. We're going to get 3 with a remainder of 1. So that's going to give me the remainder, and that's why we get 1 over here. I also want to show you guys order of operations. So I have this little equation here, 1 plus 2 times 3. Now what this is going to do is it's going to multiply the numbers first. So it'll do 3 times 2, 6 plus 1, and that's why we get 7. But I could put parentheses around the addition. So I could say 1 plus 2 times 3. And now if I run the program again, this is going to change things up. So now we get 9 instead of 7 because it's 1 plus 2 is 3 times 3 is 9. I also want to show you guys how ints and doubles interact. So remember, we have ints, which are whole numbers, and doubles, which are decimal numbers. So if I take an integer like this 10 and I divide it by a double 3.0, you'll see that I get a double answer. So I get 3.3 repeated back. But if I was to take an integer and divide it by another integer, so if I change this to 10 divided by 3, both of which are going to be integers, then we just get an integer answer back. So that's kind of how that works. So if you're doing math on two doubles or a double and an integer, you're getting a double back. If you're doing math on two integers, then you're getting an integer back. All right, so down here, I want to show you guys some other operations. So I just have this integer called num, and it's equal to 10. And what I can do is I can say plus equals. So this is a shorthand. Basically what it'll do is it'll add 100 to the value stored inside the num variable. You see over here we get 110 because it added 110 together. You can do plus equals, minus equals, divide equals, and multiply equals. And then you can also do plus plus. So plus plus is basically just going to increment the number. So you see down here, we incremented it and we got 111. You can also use the Java math class, and Java has this awesome math class with a bunch of awesome methods inside of it. So I can just say math with a capital M, and this is actually what's called a static class, so I don't need to create an instance of it. I can just say math dot, and then you can access the method name. So there's a couple here, like POW will give you a power, so it'll take 2 to the third power, we get 8. Square root will give us the square root, we get 12, and then round will round the number according to standard rounding rules, we get 3. Again, if you just go online and search for Java math class, then you'll find a bunch of these awesome methods. All right, let's talk about user input. So obviously, as in all other languages, there's a bunch of different ways that you could go about getting input from a user. But if we want to get input from the user in our console or our command line over here, then we can use something called the Java scanner. The scanner is actually a class, so I'm actually creating an instance of that class down here. I'm just saying scanner. I'm calling it keyboard input, and I'm setting it equal to a new scanner. And inside of here, I'm passing in system.in. And system.in basically represents this console over here. Now, whenever I want to use this scanner, I have to import it. So you'll see up here at the top of my file, I have this import statement. And you can import, external Java code into the code that you're currently using. So it's important that you include that import statement. So down here, the first thing I do is prompt the user. So you'll see over here, the user is getting prompt to enter a username. And then down here, I'm creating a string called username, and I'm setting it equal to keyboard input dot next line. And next line is a method which is basically just going to grab whatever line the user enters into the command line. And then it's going to store it inside of this username variable. And then down here, I'm just printing out hello username. So if I was to type in my name up here, Mike, now you'll see it says hello Mike, just like that. So we prompted the user, we got the information from the user using that .next line method, and then we stored it inside of the username variable. In addition to next line, you can also use .next double, and you can use .next int. So that's how you can get doubles and integers from the user. And obviously, if you get a double or an int, you're gonna have to store it inside of an int or a double instead of a string. You can also check to see if what the user entered is valid. So you'll see down here, I have like keyboard input has next line, and that'll give you a Boolean value depending on if the user entered in what they were supposed to enter. So if they entered in a line, or you can do the same thing for has next double and has next int. No programming tutorial is complete without an explanation of arrays. In Java, because it's statically typed, you can only store one particular data type inside of an array. So when we want to create an array, we can basically specify the type of information that we want to store. And then I can make this open and close square brackets, give it a name, and then I can set it equal to some initial values. So I'm going to put the initial values inside of curly brackets like this, and you'll see array indexes start at 0. So we would say that 4 is element 0 in the array. It's at index position 0. 8 is at index position 1, etc. So the indexing of arrays works like the indexing of strings. And down here, I can access an individual element in the array just by going like that. So I can say the name of the array, and inside of square brackets, the index position. And then if you want, you can like set it equal to a different value or whatever. So you'll see down here, I'm printing out lucky number 0. We get 90 because we just assigned it up here. Lucky numbers 1 is going to be 8, and that's because we have this 8 over here. And finally, you can access the length of the array. Now, the array length is an attribute of the array, so it's not a method. So we don't want to put open and closed parentheses there. You just want to put dot length. And again, this is going to give me 6 because there's 6 elements in this array. A lot of times though, when you create arrays, you're not going to know what you want to put in there initially. So what you can do is something like I have up here. So you can just say int lucky numbers. And then you can just say new int, and then inside of square brackets, it's just going to be the number of elements that you want to store. So you have to tell Java how many elements you want to store inside the array. So now if I was to run this code, you'll see that we still have lucky number 0 equal to 90 up here, but lucky numbers 1 is going to be equal to 0, and it's going to have 10 elements inside of it. So the length's going to be 10. And whenever you create an array like this, everything gets initialized to 0. Java can also support n-dimensional arrays, so like 2 or 3 or 4 dimensional arrays. Over here I have a 2-dimensional array, and you'll see I just have 2 open and close square brackets. I'm calling it number grid, and then over here I'm giving this some initial values. So you'll see I have these open and closed curly brackets, and then inside I have some more curly brackets. So these are 2 arrays inside of a single array. And again, we can access those by just accessing the particular array element. So that would be like 0 or 1. And then over here is going to be the individual element inside of there. So this would be like 0, 1, 0, 1. So you'll see down here, I'm setting position 0, 1, which is going to be this 2 equal to 99. So if I print out 0, 0, this is going to give me 1. If I print out 0, 1, this is going to give me 99. And you can see that's what we get over there. For the most part, these behave just like normal arrays, except they're n-dimensional. In addition to just normal arrays, you can also have a dynamic array list. And this is just an array that you can like insert elements into. You can use all sorts of methods on it. And it's called an array list, and it's actually a class. So over here, I'm importing java.util.ArrayList, and down here I'm creating an array list. So I'm just saying array list, and then inside of open and closed greater than less than signs, I'm declaring what type of information I want to store inside the array list. So in our case, it's going to be a string. I'm giving it a name, and I'm setting equal to new array list. Again, the type, and then an open and closed parentheses. And down here, now that I have this friends array list set up, I can just like dynamically add stuff. So I can say like friends.add, friends.add. So I'm adding 3 elements, and then down here I can print it out. So I can say friends.toString, and you see up here, this prints out the contents of the array list. And then you can also like get a particular element. So I could say like friends.getZero, and this will get the 0th element. You can see we're getting Oscar over here because that's the element at index position 0. You can also say friends.contains, and this is going to return a Boolean value. So it'll tell you whether or not an element is inside of the array list. So I'm saying friends.contains Oscar. That's true because Oscar's in there. And then we can get the size, which is going to be 3. If you want, you can also remove elements. So here I have friends.remove. So I'm removing this Oscar element. Now, if I was to run this program again, you'll see that the array only has Angela and Kevin. And now friends.getZero is going to give us Angela, and the array no longer contains Oscar. Let's talk about methods. So a method is basically a way that you can take code and put it into its own little container, and then you can call the code inside of that container, and you can reuse it and do all sorts of stuff with it. So in Java, all code needs to go inside of methods. So up here I have this main method, and this is a special method. It's basically the method that gets executed when you run the file. So whenever I do that Java run command, the main method, the code inside the main method is going to get executed, but I can make other methods. So down here I created another method, and basically I just said public static int, and I gave it a name. So Public is just the security modifier, so it basically determines who can access this method. Static is a special keyword that we're going to talk about later. Basically means that this method belongs to this app class. Now, generally, if you're making a method in Java, you don't need this static keyword. But if you're making a method alongside of this main method and you want to be able to access it directly, then you need to put this static keyword here. And again, that's just because it's going next to this main method. And then I can declare a return type. So this is going to be a data type that's going to get returned by this method. And then I can give it a name. And then over here, I can declare some parameters or arguments that this method's going to accept. So I have two int num1 and int num2. And then down here, I'm just returning num1 plus num2. So this method's just adding the numbers together. And you'll see over here, I'm creating an integer called sum, and I'm setting it equal to the result of adding 4 and 60. So this method is going to return the result of adding the numbers, store it inside of the sum variable, and then you'll see I'm printing it out over here. So we get 64. And these methods can return any data type. They can return any object. They can basically return anything that you can represent in Java. All right, now let's talk about if statements. So if statements are a staple in any programming language. You'll see over here I have two Boolean variables. One's called isStudent and one's called isSmart. They're both equal to false. Down here I have an if statement. So I can use this if statement to respond to these variables. So I can say like isStudent and isSmart. So I can use the and operator. I could also use the or operator, which is just two vertical bars like that. And so if this condition's true, then we'll execute the code down here. I can also use an else if. So that means if this condition's false, then we'll come down here and check the else if. And I can use the negation operator. So this exclamation point is the negation operator. So this is going to read else if isStudent and not isSmart. So this will negate the condition that we place over there. And again, we can also just have a normal else. So because both of these are false, it's going to go to the else and it's going to print out you are not a student and not smart. You can also use comparisons. So instead of just checking Boolean values, you can obtain Boolean values by comparing two different values. So over here, I'm saying if 1 is greater than 3, so that's going to be false. But if I made this 1 less than 3, now this will be true. And you'll see over here it's saying number comparison was true. So I compared these two numbers. You can also compare characters. So you can compare for equality, which is going to be a double equals, or you could do like greater than or less than, etc. And if you want to check to see if two strings are equal, you can use this dot equals method. So you can have the string dot equals and then pass in another string just like that. And the different comparison operators are greater than, less than, greater than or equal to, less than or equal to, not equals, equals, and then like I said, string dot equals will check to see if two strings are equal. So that's kind of the basics of comparisons and conditionals. So in addition to normal if statements, we can also use a switch statement. And a switch statement is basically just a specialized type of if statement. It'll allow us to check a bunch of different cases. So here I have this character, it's called my grade, and it's just an A. And over here I can say switch and then pass in that variable my grade. And down here I can define a couple cases. So I can say like case A, case F, and then there's a default case. So basically this says in the case that my grade is equal to A, then we want to do all this stuff down here. So down here I can just put something that I want to do. So in the case that the grade's A, I'm printing out you pass, and then I have this break statement here, which is going to break me out of the switch statement. And I'm doing the same thing for F. And then if neither of these cases are true, we have this default statement. So over here it's A, it says you pass. If I was to put an F into here, now it's going to tell me that you fail. If I put a Z in here, that's not one of the options, so it'll default to invalid grade. Next up is while loops. While loops is a very general loop that allows you to loop over a block of code while a certain condition is true. So over here I have this integer index that's equal to 1. And while index is less than or equal to 5, so while this variable is less than or equal to 5, I'm just going to print out the value of the variable and then increment the variable. So you'll see over here I'm printing out 1 through 5, and that's because once this gets to 5, when it gets incremented, it's no longer less than or equal to 5, so we break out of the loop. One thing you want to watch out for are infinite loops. So if I got rid of this index plus plus, this would give me an infinite loop because this variable is never going to be greater than 5. Another type of loop that you can use is a do while loop. So it's essentially just a while loop, but it's the opposite. So in a while loop, you check this condition first, and then you execute this code. In a do while loop, you execute the code, and then you check the condition. So even if index up here was equal to 6, I'd still be able to execute one iteration of this do while loop because, again, you're executing the code and then you're checking the condition. But both of those are going to be valid in Java. In addition to while loops, we also have for loops. And a for loop is essentially just a specialized version of a while loop. It's like a more compact version. For loops allow you to keep track of an iterating variable. So I have a variable over here. I can say int I is equal to 0, so I'm declaring and initializing a variable. And then over here, I'm specifying the condition, so the looping condition. I want to keep looping as long as I is less than 5. And then over here, this is just a little line of code that'll get executed after every iteration of the loop. So it's just going to increment I. And then down here, I'm just printing out I. You'll see over here, we're printing out 0 through 4. So we're printing out 5 times in total. And for loops can be really useful, again, if you have a situation where you want a variable I, which is going to change every time we go through the loop. You can also use an iterating loop. So this would be like a for each loop. Basically what this will do is it'll allow you to easily iterate through a data structure like an array. So over here I have an array with a bunch of numbers in it. And what I can do is say for, and I can again define a variable that's gonna change every time we go through the loop. So int lucky num. I can make this colon, and then over here I can put the name of the structure. So in our case, like I said, it's an array. So I can say for lucky num. So basically for lucky num in lucky nums, and then I'm just going to print out lucky num. So over here, we'll basically be printing out every number inside of that array. So this, again, this is like a for each iterating loop. Another staple in any programming language is exception catching. So how do we deal with things that go wrong? So over here, I'm going to show you an example of an exception. So we have this division variable, and I'm trying to set it equal to 10 divided by 0. So it's impossible for us to divide by 0. And you'll see over here in the console, we get this exception. It says that it's a arithmetic exception. Exceptions will actually terminate the program, so they'll break the program. What we can do is we can handle those exceptions. So I can create what's called a try catch block. You'll see over here I just have try and then an open and closed curly bracket, and then down here I have catch. So any code that I think might break the program, I can put inside of these try blocks. And then I can put a catch block, which will catch an exception. And you can do one of two things in this catch block. You could try to catch a specific exception, like this arithmetic exception, and then you could set it equal to E, and in which case this will catch the arithmetic exception, store it inside of this E variable, and then we can print it out. So now if I was to run this program, you'll see that it's just printing out the exception, but it didn't actually terminate the program. And then you can also have just this general exception over here, which will catch any exception under the sun. This is not a good practice though. Generally, you don't want to catch like just any exception. You want to catch a specific exception. But the point is that you can specify multiple types of exceptions that you want to catch and do different things when those exceptions occur. You can also throw an exception. So down here, I have this code and it's just throw new arithmetic exception. And then over here, I'm just passing in the message for that exception. So now if I run my program, you'll see that this exception gets thrown and it's an arithmetic exception. So if you want, you can have your code throw exceptions, or you can have your code catch exceptions. So now let's get into object orientation. So I'm going to talk to you guys about classes and objects. And what we can do is we can actually create a class, which is essentially just a custom data type. And so over here next to this class app, I can actually create another class just like that. Or a lot of times what people will do is they'll put classes inside of their own Java files. And actually that's probably a best practice, is to put all your Java classes inside of their own files. But in this case, for the purpose of the demonstration, I'm just going to put the class alongside of this class we've been working with. So I have this class book, and over here I can declare a couple attributes. So I can say like public string title, public string author, and public, that keyword basically means that this attribute is accessible to any other Java code in our program. So again, these are just attributes. And then over here, I also have another attribute. This is a static attribute. And a static attribute means that this attribute belongs to the book class. It doesn't belong to a specific instance of the book class. And this is just a string. It's just my static attribute. And down here, I have a method. It's called readBook. And you'll see over here, it just is printing out reading this.title and this.author. So when we say this dot and then the name of the attribute, it refers to the title and the author of the specific object of this class that we're creating. So that's how you would access a specific attribute of the specific object. And down here, I'm creating an instance of this class. So I'm creating an object. So I'm basically storing this object inside of a variable. So I'm defining the type of the variable. It's the book data type, and I'm giving it a name book1, and I'm setting it equal to a new book object. So this over here is the type of variable that I'm creating, and this over here is the actual object. When you create a new object, you can just say new book, and then these open and closed parentheses. And then I can assign the attribute. So I could say like book1.title is equal to Harry Potter, book1.author is equal to J.K. Rowling. So I'm populating the fields of this object. Once the object fields are populated, then down here I could call this method, for example. So I could say book1.readBook, and you'll see over here it says reading Harry Potter by J.K. Rowling. So this readBook method was able to grab the title and the author that I assigned down here inside of that method. And I can also print out like book1.title, so it's Harry Potter. And then if I wanted to access that static attribute, remember the static attribute is a class level attribute. I can just say book with that capital B, so it's the name of the class dot static attribute. So I don't need to create an instance of the class to access that static attribute. Another thing we can do, which will make our lives a lot easier, is use constructors. A constructor is basically a special method which is going to get called when we create an instance of a class. So up here in my book class, I added a couple constructors. So I'm creating this constructor by saying public, the name of the class, and then an open and closed parentheses. And down here, I'm just saying this.title is equal to no title, and this.author is equal to no author. You can also create a constructor where the user can pass information. So I could say book, and then I could specify that the user is going to pass in a title and an author, in which case I'm populating the title and the author fields with the title and the author that they got passed in. So down here, I'm creating a couple books. So I'm saying book1 is equal to new book, and then here I'm passing in Harry Potter, and I'm passing in J.K. Rowling. Down here, I'm passing in Lord of the Rings or Tolkien. I could also get rid of these, so I could just use this empty constructor. And now when I run this program, you'll see the title is Harry Potter or the title is no title, depending on which constructor we called. So constructors can make your life a lot easier. Another thing we can do, and another thing that's popular to do in Java, is use getters and setters. And getters and setters are basically special methods which control access to class attributes. So what we can do over here to implement getters and setters is I can come up to one of these attributes. So for example, this author attribute, and I can set it equal to private. And what private means is that only code inside of this book class can access it. So only code in the book class can access the author. And because this is private, that means that if I was to create a book like I did down here, I'm not going to be able to directly access the author. What I can do is I can create two methods inside of the book class, get author and set author. And the get author is basically just going to return this .author. Set author is basically just going to set the author equal to whatever the user passed in. And the idea is that inside of these getter and setter methods, you could put different types of code that would control the access that the user has to those class attributes. And then over here inside of the constructor, so here's my constructor. When I set the author, I'm just saying this.setAuthor. So even in the constructor, I'm using that setter. And down here, you'll see I created this book. And if I want to get the author, I have to say book1.getAuthor. I can't just directly access the author attribute anymore. Another really useful feature in object orientation and in Java is inheritance. Inheritance is basically where a class can inherit all of the attributes and functionality of another class. So over here, I have an example of inheritance. You'll notice that I have this class up here. It's the chef class. And the chef class can do three things. You can make chicken, can make salad, and can make a special dish. And each of these basically just prints out what the chef is doing. And then down here, I have another class called Italian chef. So Italian chef is another type of chef in my program. And you'll see over here, Italian chef, and I have this extends keyword chef. So the Italian chef is now extending, or it's inheriting all the attributes and functionality from the chef class. And I'm also adding in a make pasta method. So down here, you'll see I have this chef object, and I'm telling the chef to make chicken. Then I have this Italian chef object, and I can also use this make chicken method on the Italian chef, even though the Italian chef never defined the make chicken method. Because it's extending the functionality from the chef class, it's able to use that make chicken method. So you'll see over here, they're both able to make chicken. When you're using inheritance in Java, you can also override functionality from the superclass. So you'll see over here, I have this @override keyword up there, and then I'm saying public void make special dish. So I'm overriding the make special dish method from this chef class. So the Italian chef is going to make a special dish of chicken parm, whereas the normal chef would make a special dish, just like a general special dish. So now if I have both of these guys make special dish, you'll see that the chef is just making like a generic special dish and the Italian chef is making chicken parm. So that's the basics of inheritance. And also up here in this Italian chef, I added an extra function, make pasta. So that's something that only the Italian chef can do. And that's basically how inheritance is going to work. All right, next thing I want to talk to you guys about is using constructors with inheritance. So over here, I have basically the same setup as before. I have the chef class, but I actually define two attributes on the chef class. We have name and we also have age. And then down here, I have a constructor for the chef. So you'll notice the constructor takes in name and age, and it's basically just setting them. So the chef can have two attributes, a name and an age. And then down here in the Italian chef class, I actually added in an extra attribute. So the Italian chef can have the name and the age and can also have the country of origin. So over here, I basically defined a custom constructor for the Italian chef class. So it just says public Italian chef, and you'll notice that passing in a name, an age, and also a country of origin. And then down here, the first thing I'm doing is I'm actually calling the superclasses constructor. So I'm saying super name age, and what that'll do is it'll initialize name and age using that constructor that we already defined up in the superclass. And then over here, I'm just initializing the country of origin with the country of origin that got passed in. So that's basically how you can use the superclass constructor alongside of a subclass constructor. And then you'll see down here, I have the chef object, I'm passing in Gordon Ramsay and 50, and then I have the Italian chef object passing in the chef, the age, and then also that additional attribute, which is the country of origin, in this case, Italy. And then down here, I'm printing out my Italian chef.age. So you'll see we get 55. So that's basically how that works. Inheritance is a big topic in Java. And another way that we can use inheritance is by using abstract classes and abstract class attributes. So over here, I have an abstract class vehicle and public abstract void move. So this is an abstract method. Basically, that means that inside of this abstract class, this abstract method isn't actually going to get implemented. So all I'm doing is just defining this move method. I'm not actually implementing it. And then any of the subclasses that extend the vehicle class can actually implement this move method. So you'll see up here in the vehicle class, I'm not implementing the move method, but down here in this bicycle class and in this plane class, I'm actually implementing it. So here I have the move method, and then down here in the plane class, I also have the move method. So down here, if I created an instance of the plane class, like I created a new plane, I can say myplane.move, and you'll see it says the plane flies through the sky. So it's executing this move method that we defined inside the plane class. And if I say myplane.getDescription, you'll see that getDescription was actually defined up here inside of the vehicle class. And so it's going to go ahead and print that out. So abstract classes basically allow you to specify that the subclasses should implement specific methods. All right, the last topic I want to talk to you guys about in regards to object-oriented programming is interface inheritance. Basically, we're able to define interfaces which subclasses can then implement. So over here, I have an interface. It's called animal, and you'll notice that this just has one method inside of it. And basically, an interface is an abstract class that has all abstract methods and attributes. So over here, this is essentially like an abstract class, but everything has to be abstract. So over here, we have interface animal, and I have this one method, public void speak. And so now what I can do is I can define subclasses which will implement the animal interface. So over here I have class cat. So I have a cat class and it's implementing this animal interface. And then over here you'll see I'm overriding the speak method, and I'm just saying system.out.println meow meow because the cat says meow. And then down here I have a dog class, and the dog class is implementing the animal interface. And again, I'm overriding one of the methods. I'm overriding the speak method, and the dog says woof instead of saying meow. So I have the dog class and I have the cat class, both of which speak differently. So the cat speaks differently than the dog speaks. But both of these, since they're implementing the animal interface, are still considered to be like the animal data type. So down here in my program, you'll see I'm actually creating an array. So over here, I have this array, and inside of this array, I'm storing animals. So this array can hold animal data types, right? But inside of the array, I can create a new dog object and I can create a new cat object. So even though these are two different objects, even though this is a dog object and this is a cat object, both of them, since they're implementing the animal interface, are technically animal data types. So they can both sit inside the same array. And then down here, you'll notice that I'm basically just iterating through all of the animals inside of this animals array, and I'm telling each one to speak. And the first time through, it's the dog object. So the dog object is going to say woof woof. And the second time through, it's the cat object. So the cat object is going to meow. So that's really cool. Basically, you can define interfaces, which defines like an overall data type. And then subclasses can implement that interface. And technically, they're all the same type, but they're different classes. So that's why interface inheritance, or you also hear people refer to this as polymorphism, is really useful. So that is a pretty good overview of all the different things that you can do in Java. Obviously, I didn't cover everything, but I think that is kind of like all the main stuff that you're going to use when you're first getting started. Obviously, you know, Java is extremely well documented, so anything that you need, you can just look up. But hopefully that gives you guys a good jumping off point to go into the Java programming language. Hey, thanks for watching. If you enjoyed the video, please leave a like and subscribe to Draft Academy to be the first to know when we release new content. Also, we're always looking to improve, so if you have any constructive criticism or questions or anything, leave a comment below. Finally, if you're enjoying Draft Academy and you want to help us grow, head over to draftacademy.com/contribute and invest in our future.